Alright, so welcome back. In this video I'm going to talk about degree and order for polynomial functions. Now in polynomial functions I'm going to try to explain it through a few examples. First I'll talk about kind of the degree and order of a term of the polynomial, and then the degree and order of the entire polynomial, and in this case a function. So let's take a step backwards and kind of go back to power functions. So I'll put up a link to power functions, if you want to recall, but I would want to do a little bit of a deja vu for you and say that, well, for these power functions, and I'm interested actually in power terms because we're going to need them, we had some constant a, and I'll put a subscript n on it. I'll explain what the n actually means in just a moment. So we have some constant, so some number, which is a real number. It could be positive, it could be negative. We'll assume that it's not 0, because if we take it as 0, then it would erase everything for us. And then we're going to multiply this constant by the variable x and then raised to some power n. Now this power n, so this n right here, I guess it's the same n as right there, we're going to assume that it's kind of a natural number. Now if it's a natural number, then it can take on a 1, it can take on a 2, okay, a 3, a 4, and so on and so on. So it can't be negative, it cannot be a decimal, and it cannot be a fraction. So if that's the case, then what I would want to do is I would want to just show you that all of these functions, I'll take the first one, are nothing else but simply the addition and subtraction of these power terms. Now here in the first one, so I have a 3, and then it says minus 4x, and then I have plus 2x to the 3. So if I take any of these terms, I can kind of relate it back to this power term that I just described. So for instance, if I would take this 4x, I can say that, oh, well, if I take 4x, then this, really what it means is that my exponent here is 1. So my a of 1 is going to be this 4, and then it's being multiplied by x, okay, and then it's a 1. But in math, we drop the 1 because we know that it has just an exponent of 1. So that would have been one particular power term, and that has an order of 1, or a degree of 1. Now, where does that come from? It actually comes from right here. So that's the degree or order that we're looking for. It is the exponent or the power of that particular term that we have. Now you might say, well, what about this first term? Well, this term doesn't have an x. So if it doesn't have an x, we say that that has a degree or order of 0, okay, because it doesn't have any variable in it associated. So it's just a constant. Now this third term that I have, which is 2x to the power of 3, that would have a degree or order of 3 because of that particular exponent. Now, because we can describe every single term, you might ask, well, what about the entire function? What order or degree is that function? So this f of x, what is it for that entire polynomial? When we do that, we always take the highest order. So in this case, the order of all the terms, the first term was order 0, the second term was order 1, and the third term was order of 3. So we say that that polynomial, f of x, has a degree or order of 3, okay, because we took the largest value. Now, if I would take a look at the second polynomial, so here I have a negative x squared plus 10x. So again, I can break it down for every single term, and I can say, well, my first term right here has an order or degree of 2, and my second term, which is just the 10x, has an order or degree of 1. So if I wanted to know what the degree or the order for that particular polynomial function is, I would say that it's 2, because that's the largest one that I carry. Now, in the last one, this h of x, you can probably very now quickly kind of take a look and scan and say, all right, well, this one has an order or degree of 10, because that is the largest exponent that I have on my power terms. So, and this is the one that would be the dominant one. which is x to the 10, and then it has a constant of 2. Now, the second term, indeed, it has an x to the 3, so it's definitely not a small order, but x to the 10 overpowers it. And then the last one right here, this is just a constant, that would have been degree of 0. So in general, when we write these polynomial functions, we basically are just adding and subtracting polynomial power terms. In general, okay, so since we're just adding and subtracting these, we typically write this polynomial function in this. And it is just nothing else but an addition, okay, of all of these different terms that I have. And we ideally, we would want to put the highest order first, and then it reduces in order and it continues on. Now, of course, you may not have every single order. So if, for example, n was equal to 5, that doesn't mean that there's going to be one meaning a term that has an x to the 4 and then an x to the 3. They may not exist. I mean, we saw this right here with this example. Our last example has a degree or order of 10, but yet notice there was no x to the 9, x to the 8, x to the 7, and so on. What that would mean is, that would simply mean that those constants, those values of a, for those were simply 0, and we don't have them. All right? Okay, so this is all I want to mention about the order and the degree of a polynomial function. And hopefully now, okay, if you hear it, you know what whoever your teacher or somebody who is describing is referring to. All right, thanks for watching. See you in a future video. Bye.